Okay, so I had a quick question about number 4 on, from section 4 of the review. So this is it here. I lost the top of it, but you can see basically what it looks like. The solutions are shown, so just sort of a matter of figuring out why the solutions are coming up the way they are. My guess is that the first part is not an issue, but we'll sort of take a quick peek at it as well. So if I look at the first one, sine A is this value. We do the inverse sine. Okay, so my calculator is set to degrees, first of all. Make sure yours is as well. Inverse sine, and it's 0.6678. Hit the equal sign, and we get just about 42. Okay, so there's our first answer, of course, right in here. Now, the thing to remember is from this diagram down below, we have what we call the cast rule. And the cast rule tells us that as we rotate through a full 360 degrees, okay, so here's our 42 degrees. I'll just use 42 for the sake of the video. Here's our 42 degrees here. But as we rotate through 360 degrees, we have the same, or we have an equivalent ratio in here, here, and here as well, of, again, 42 degrees in each case. Now the cast rule tells us that down here, cosine is the only positive ratio. Up here, all the ratios are positive. Here, sine is positive. Here, tan is positive. So because my original question said I'm looking for the value that gives me positive 0.6678, I need to find the two areas. This is always going to be one of them. And in this case, this is the other one. I need to find the two areas where sine is positive. And so here's where sine is positive. Anywhere between 90 degrees and 180 degrees, sine is positive. And so then the last step is just to determine what is this second angle, the one that goes from here to that spot there. And so if this is 180 all the way to here, I subtract the 42. Again, I was using 41.9 here to get the second angle, the 138 approximately, that gives me the same value. And if you needed to check that, you just do regular sine of 138, and you see that you get basically the same number. Again, it was 138.1, so maybe if I do sine of 138.1, it'll be that little bit closer again. Okay. I'll do one more here just to sort of make sure it's a little bit more clear. And so it doesn't really matter which one. I guess I'll look at one of the cosines here, cosine for D. So I'm doing the inverse cos of this root 3 over 2. Now this was one of the special triangles that we kind of memorized, and so the angle's 30. But again, if you don't remember that, it's not the biggest deal in the world. You can just punch in, we're trying to find the angle, so we have to use the inverse, so it's the inverse cos. Punching into this calculator is a little tricky, but it's root 3. Then I close off that bracket, divided by 2. On the calculators, it's a little bit nicer. That should give me an angle of 30. And then again, same argument as before. 30 is now the angle on the inside here that I'm interested in. So all of these would be the equivalent of 30. And then I'm looking for the areas where cosine is positive. Of course, this is the one. And then the second is all the way around right here. Since 360 degrees would take me all the way back to the start, I subtract the 30, and I find 330 is my second angle. Hope that helps.